In this lesson, we're talking about the Pythagorean theorem. We'll solve a number of problems using the Pythagorean theorem and determine whether a triangle is a right triangle. With this, there are some new vocabulary words that we're going to be introduced to. We're going to talk about a hypotenuse. We're also going to talk about legs. And then we might mention the converse relationship, and then also the Pythagorean triple. So, taking a look at the vocabulary, in a right triangle, there's always one corner that's a right triangle, and that's designated by the square in the corner. And the sides that are adjacent are called the legs. They're also the two shorter sides. The side opposite the right angle, so if we were to look straight across, is called the hypotenuse. Kind of think it's a fun word to say, so go ahead and say that 10 times quick. Okay, really nobody's there to listen to you. But the hypotenuse is always opposite the right triangle. And for those who really want to understand or know about the Pythagorean theorem, it was named after a Greek mathematician, Pythagoras. And he just noticed the relationship between the sides of a right triangle. So, what does this say? The Pythagorean theorem basically says that the two shorter sides, A and B, when those are squared and added together, will equal C squared. So, the book tends to use C squared equals A squared plus B squared. We also might see it as A squared plus B squared equals C squared. And knowing that fact, we can use this to solve a variety. So, here we have a problem. They're saying find the length of the hypotenuse of a right triangle. A is 8, B is 15, so we're trying to find C. So again, just using the formula, A squared plus B squared equals C squared, we're going to substitute for what we know. A, we're told, is 8. So we have 8 squared plus B squared, which happens to be 15, equals C squared. So we have 64 plus 225 equals C squared. At this point, it's helpful to have a calculator as we solve this and go through this. So we get 289 equals C squared. Again, as we work through this, keep in mind that we undo addition with subtraction, undo multiplication with division, and we're going to undo a square using a square root. So I get C equals the square root of 289, which happens to be 17. Keep in mind that the square root of 289 could be positive 17 or negative 17. In this case, only the positive answer makes sense. We can't have a negative distance. So our answer is C equals 17. Okay, so here we have another example. Go ahead, take a moment, try this one, and then hit pause to see how you do. So the first thing we need to do is set up the equation. 7 squared plus 13 squared equals C squared. Know that 7 squared is 49, 13 squared is 169, and we get C squared. So we have 218 equals C squared. Again, at this point we need to do the square root of these, and that ends up with a number that goes on and on forever. We'll go ahead and just round to the nearest hundredth. So we get C equals 14.76 as our answer. So here we have an equation, or a triangle, where B and C are given, and we're asked to find A. So we have A squared plus B squared, which is 10, equals 225, equals 25 squared. So we're going to solve the equation for A squared plus 100 equals 625. So we solve for A, we need to subtract 100. Subtract 100, and we get A squared equals 525. Again, at this point, you'll hear me say over and over again, we rely heavily on a calculator, round to the nearest hundredth when we take the square root of these. And we're only concerned about the positive answer. The negative answer would not make sense in this case. So we get 22.91. So here's one for you guys to try on your own. Again, hit pause, check how you do. So put in for a squared, that's 6 to the second, plus b squared equals 14 to the second. So we have 36 plus b squared equals 14 to the second, which is 196. Subtract 36 from both sides, and we get b to the second equals 160. Go ahead and square 160, and you get 12.65. So we have b equals 12.65. Again, on the calculator it said 12.649, but we're rounding to the nearest hundredth. Okay, so a Pythagorean triple is just a set of sides that happen to make a right triangle. So a common example that we use is 3, 4, 5. Another one we use is 5, 12, 13, and so on. As a lacrosse coach, part of my duties is to line the fields, and I often find myself trying to make a field that is a right angles. I don't want a parallelogram. If I set up the field this way, I end up with a field that the measurements all work, but my angles are not right angles, and so the field doesn't quite work for practice purposes. And so I'll end up using the Pythagorean theorem as I set my first corner, and I'll double check the second quarter to make sure I'm not going sideways with my field. If I were asked a question like this one that we're given, what is the area of a triangle ABC? I don't know the side right here. But because it is a right triangle, we could solve it by going 12 to the second plus b to the second equals 20 to the second. 12 to the second is 144. B to the second, we don't know, and we get 400. So we can go ahead and subtract 144, subtract 144, and you get b to the second is 256. Again, we'll take the square root of that and get b equals 16. Once I know that information, going back to what we know about triangles, the area equals 1/2 the base times the height. So in this case we have 12 times 16. That's going to give us 192. Divide that by 2, divide by 2. We end up with 96. So the answer to this one should be A. So don't know if we'll need to know that this year or not, but it's good knowledge and we can use it later. So if I exchange the hypothesis and the conclusion, and if-then statement, we get the converse. So if I'm given 3 lengths of a triangle, maybe they tell me I have 3, 4, and 9. Okay? If I know that these two are equal, then I know I have a right triangle. In this case, so 3 squared plus 4 squared, we can check to see, does it equal 9 squared? We have 9 plus 16 equals 81. 25 does not equal 81. So these 3 sides could not make a right triangle. So I can test any 3 sides. Here we have a couple unique measurements. If you want to hit pause and try them, you can. For the purpose of the video, this is just practice for you guys. And if you're really interested, we can go through these in class tomorrow.